Hello and welcome to this new tutorial series about Seaborn data visualization package of Python, and this is the official site seaborn.pydata.org, and some introductory text is written that this library is based on matplotlib. And if you have seen my previous videos, I've been talking about the matplotlib library and its related visualization. So while matplotlib is great, I think Seaborn is the next level of visualization, which is based on again matplotlib, and it provides, as it is mentioned over here, a high level interface for drawing attractive and informative statistical graphs. So again, it is very easy to understand, and it has this page has, as you can see, its gallery, its tutorial, very detailed tutorial, the API, information about the site, and the different pages. So what I will going to show you in these new tutorial series is visualizing based on some real data set. That means not with the something which is inbuilt, but something which is real, like I've been showing you about the sales orders data from a grocery store. So over here, that's what we will going to do, and jump very quickly about the different commands through which we can create the relational chart. So when I say relational, that's like understanding the relationship between two variables, and one of the best chart to understand that is scatter chart. So we'll see what is a function and what are the different parameters that we can give to create the stunning scatter charts. So over here I was importing the Seaborn library, so import Seaborn as SNS, and I will also import the pandas because I will import that data set. So now it will took like 1 second to import it, and I will import the data set, which is sales data set. So pd.read_excel, as you can see, this one, and over here I will say sales.xls. So this default parameter will look for the sales file, and by default it will going to pick the first sheet. But if your data is in any other sheet, that you can specify the sheet parameter, which is like this, sheet_name. You can give a sheet name if you want to pick any different sheet. So sales is here. If we just look at first couple of rows using the sales.hat, what it has is the order ID, order date, order priority, quantity, sales, and so on and so forth. Very it's a good data set to do an analysis on. So that's why I just wanted that instead of a very simple small data set which is like of 100 rows or 200 rows, let's take something which is closer to the reality. All right, so the next thing is let's say we want to understand what is the relationship between two variables, and maybe the variable of our interest is sales and profit. So what we can do is, SNS is the library name. As you could see, SNS is something what we created an alias for Seaborn library so that we don't have to write Seaborn again and again. So sns.rel plot, which is relational plot, and it takes 3 parameters by default. So first one is the sales, which is the sales column. Second one is the profit column, so profit is Y, and so sales will be on x-axis, profit will be on y-axis, and then data equals to sales object, which is this. So I hope this is clear. This is the minimum parameter that we need to provide to REL plot, and once we entered this, I press the shift enter, and this is a chart which has been created. And it shows that in some cases profit is below 0 and even reaching to minus 10,000, so something very interesting. And then in some cases, as you can see, the sales is increasing, the profit is increasing, and definitely this piece is an outlier. So we will now move on to something different. So for example, we have the sales and profit, but as you can see over here in this data set, we have different variables like order priority, which is the categorical variable, having low, high, not specified, and probably critical also as the order priority. Similarly, you have ship mode as regular air, delivery, truck, and I think there is another one which is express air. So you have different types of categorical variables. Similarly, you have customer segment, you have product category, product subcategory, which is the good case of categorical variable. So what you can do is you can color code this chart with the help of these categorical variable. So what I'll do is I'll just copy this, all right, and I will use the parameter which is hue, and within that I can mention order priority. If I just execute that, you will see now the chart is much more interactive, where you can see where my high order priority orders are, where is my medium priority, where is my low priority, and where is my critical priority. So for example, this is a critical priority. Let me just expand this a little bit so that you can clearly understand, and I will just hide header and maybe this toolbar. All right, so I think it will be much better over here. So clearly you can see where you have low, where you have critical. These are all criticals, and this is medium, like this is medium over here. Wherever you have red mark, you have medium. So this way you get to know a little bit more about the data set. So that's one way of adding the interactivity. So I'll do a copy and I'll show you another way of adding the interactivity. So if I just paste it over here, now the next parameter, so hue is helping us the color coding of value. So you have the option where you can have order priority, but apart from hue, you have one more parameter which is style, and within that again I will mention the order priority, and we'll see in action what really happens. So now if you see, we have color coded but we have the different marks over here. So circle represent low, blue circle represent low order priority, orange cross indicate high order priority, square indicates not specified. So clearly you are having much more visibility, not just the color, but with the help of these shapes you can understand much better. And then plus, red plus indicates medium, and this sort of a star shape of violet color indicates critical. So this is adding a little bit more flexibility for your eyes to better understand it. Now it's not the requirement that you have hue and style as the same parameter. What we can have is, if I just go up, so we can have order priority low, but let's say we want to style using the ship mode. So if I just go down and paste it over here, ship mode, so what will happen is you will have hue as a color coding, but style will indicate their respective shipping type or shipping mode. So if I just execute that, and now we have the color coding in all circle, but this is indicating regular air. Wherever you have circle indicating the regular air, you are, wherever you have cross sign like this one, you are, what you have is the delivery truck, and square indicate the express air. So wherever you have square like this one, I can see here, but these are like overlapping. These are data points are overlapping to each other. That's why you're not able to see a lot of picture, but it clearly indicates, along with the order priority, what are the shipping modes that you have with this. So now you are not just able to interpret what is the order priority with the help of the color code, but you are also able to interpret the respective shipping type for your analysis perspective. Apart from this, there is another pretty interesting feature that it has is the size. So if I just copy this and paste it here, and I remove the hue and this, and if I just say size, and let's say I want size by discount, so over here if I just go up, you have the discount column where you have like 4% discount, 7% discount, 1%, 8%. So based on what discount you have given, we want to increase or decrease the size of these shapes. All right, so let's try to execute that, and now you will see about the different discounts which have been given and their respective sizes. Though these sizes, as you can see, is the smallest one. This is the smallest one, so less discount has been given. This is the bit higher, but again this is not very clearly visible. So what we can do is we can tune the size parameter to indicate the different sizes other than the default one. So what do we have is, I'm just copying and pasting, and I'm saying sizes equals to it should start from 25 and let's say I'm at 200. This will make sure that sizes are looking much better and clearly visible to our eyes for comparison perspective. So if I just go ahead and execute it, you will see that the size is increased as compared to this one. Now it is much more visible, or much better visible to our eyes, and we can clearly see the difference between this and this and this. We can clearly see that these three are of similar sizes, whereas this is of small size and this is of small size, which is of 0 discount. This looks like 1% discount, this looks like 10%, this looks like 20% discount, and so on and so forth. So this way you can have the multiple option by which you can basically specify what type of parameter you can use for the better interpretation of data. So this is just the start, just to get you familiarized with the parameter that you need to pass on and the minimum settings that you need to do to make your chart very interactive for your presentation and data exploration perspective. But there will be a lot of different charts that we will be discussing and we will be going through. So I would suggest that stay tuned for that, and we will continue using this data set, or in any special scenario if I need any other data set, we will use that, and you will find the link of that data set in the description, and so that you can practice along with me. So that's about it in this first introductory tutorial, and I'll meet you in the next video with a new topic. Hello there, welcome back to the next tutorial about Seaborn tutorial for beginners. And if you remember, we talked about the scatter or the relational chart in the previous video, which was the first one. So in this next Seaborn tutorial, we will going to look at the line chart, which is a very common chart, but we will see how we can create it in the Seaborn library, along with the different options that is available to us to make it more beautiful. All right, so what do we have is, if you remember, we have the sales data which we have been using, and these are first few rows, which has sales, order priority, discount, profit, and all that, which is resembling how real life data would look like, a close resemblance to that. And let's try to build a line chart. So to build the line chart, if I don't do anything, what I will get it is like this. So sns.relplot, we will just use a rel plot using the parameter kind to create a line chart. So for x-axis, we let's say want order date. For y-axis, we want sales, and we have data equals to sales, and kind equals to line. So what it will do is it will going to create a line chart for us, And as you can see, it is taking some time because there are almost like 10,000 values which you have in this data set. So it's trying to get a connection between all those 10,000 lines by plotting the sales on top of the order date. Alright, so here is a plot which is it has plotted for us, and some warning about some features that it will deprecate. But for now, this is a chart which it has plotted, but as you can see, there are like a lot of order dates. That's why they are overlapping to each other, and same is the case with these lines over here. So what we can really do in this case is we can simplify it by extracting the year from here. So what we can do is we will going to look at or we will going to first create the year as a column, which is not right now present over here. So sales, and we have order date dot dt dot year. If we do that, now if I just say dot unique, it has created these 4 years for us, right? So the method is very simple. As you can see, the pandas data frame has these methods and properties like dt.year to extract the year value, and then using sales.year.unique values, I've just printed the number of unique values that we have got it. So if I just have to again plot it, so what I can do is simply say x-axis year, y-axis sales, I think it is capital S, data equals to sales, and kind equals to line. So now if you see, our plot looks like this, which is much better. And if you see 2009, 2009.5, 2010, 2010.5, because the year what it has considered as the numeric value. So in a background and in the data set, we can change the year. That's not an issue. But for now, the good plot that it has given us compared to this one. And we can also have like year, quarter, or monthly chart based on the property that we have utilized. But for simplicity, we have just taken the year. So over here, if you are wondering what is this shaded area over here, so what it has done is it has calculated this value as the mean, and this shaded area is the 95% plus and minus 95% confidence interval for this mean. If you want, you can change this. So if I just copy this and paste this and add a parameter which is a confidence interval CI equals to none. So in that case, the confidence interval is now removed, as you can see. Apart from this, there is another option by having the confidence interval as standard deviation. If this is something you are interested to know what is the confidence interval from the perspective of standard deviation, that's how your value is. So this is mainly for purely statistical analysis feature, that you want confidence interval as the surrounded area, or you want standard deviation, we can get based on this, and you can explore further if you are more interested in doing the statistical analysis. Alright, so the next thing what I can show you is, as I mentioned, it has taken the mean over here, but if I want to plot the right values or the actual values, what I can say is estimator equals to none, and it will show you the exact values about what happened in 2009, then in 2010, then in 2011, then in 2012. Right, so in this case it is not taking any estimator, that's why just plotting you the actual dot point and connecting those dot points. That's why you are able to see this sort of bit odd figure. We have the option where we can choose the different type of estimator. So for example this, and estimator, earlier I showed you none, now I can show you even some. So in that case, it will going to sum all the values and it will show us the output along with the confidence interval. All right. So now let's look at the option to make it more interactive. So we are looking at year and sales, but let's say we want to see it by the ship mode. So we will say hue equals to ship mode, and if we just add it over here, so now it has divided our values into the different ship modes based on the value we have given in hue. So over here, this is delivery truck. As you can see, it's completely it's like most of the orders are going by delivery truck, and then you have down there where you have regular air and express air. So using hue, you can basically take an advantage to further bifurcate the data. Apart from hue, so if I just copy this, apart from hue, if I show you another value, which is style equals to product category. Product category is a field, so I'll just show you what will going to happen in this case. So now we have hue and we have product category, both are mixed. So for example, over here, orange, delivery truck, and product category is technology. So technology is a product category which is getting shipped a lot using the delivery truck, and so on and so forth. You can go ahead and interpret it. And if you see that confidence interval is giving you nightmares, then you can have CI equals to none, and you can get a much better looking chart over here. So once you are here, the next thing that you can do is, so we have hue and we have style as product category. What I can do is I can change let's say style to something like call. So what will going to happen? It will create the three different charts in this case, because we have three different categories, which was office supplies, technology, and furniture. So now for office supply, for technology, and for furniture, these are the three different charts, which is far more better when you try to analyze it. And the good part is that the y-axis is shared, and that way you can compare the three different categories. So if I just copy this and extend the feature a little bit, so let's say we don't want product category, but we have something which has a lot of values like region, if I remember. So if I just go ahead and execute, it will show you these charts for different region. Now what it is doing is it is showing you all the chart in one single row over here. So what we can do is we can say that 1 2 3 4 5 6 7 8, it is 8, so divide the row into 2. So I'll just copy this and paste it here and say call underscore wrap is the feature, call wrap equals to 4. If I execute it, you will see a much better looking chart like this. So along with the ship mode, you will get the different region about how the shipping mode is getting utilized in different region, and you can print it in 2 different rows. If you want, you can even say 2, so that it will go into print just 2, and the figure size will be a little bit more large over here, right, like this. So this way you can experiment a lot with these features. This is right now it is only about scratching the surface or the basics we have just got to know. But with these basics, as you can see, there is a lot of things that can be done to drill down a lot into the data and do the analysis. So that's about the line chart and its different features within the Seaborn. and I hope you will utilize it a lot in your data analysis. So that's about it, and I'll meet you in the new video with a new topic. Hi there, welcome back to the next video, and in this video I will show you some more cool things related to the Seaborn library. So the data that we have, if you are following my previous videos related to the Seaborn, this is the data set that we have imported using the pandas, and we created a couple of amazing plots which are relational plot. So in relational plot, one of the thing is dividing the plots using the facets. So this is something where suppose you have created plot of sales versus profit, but you want to look at for each product category or each order priority, or maybe for each region, each customer segment, so things like that, so that you can better understand how the data is distributed there. So to do that, what we can do is, we have already imported the Seaborn library and give it an alias as SNS. So I'm directly using alias SNS rel plot, and what we have is basically sales field and profit field. If you can see over here, sales and profit, and then what we have earlier done is using the data which is sales, we have created this plot like this. And now let's say I want this plot for each customer segment, right? Like 3 different plots. So the feature is pretty easy. Call equals to and give it a name which is customer segment. So this way you will see that you will have the 4 different charts which you can analyze individually. So one chart is for small business, consumer, corporate, and home office. Allows you to look at the data individually. But suppose you want 2 charts basically so that it is bit expanded. So what you can do is you can have a parameter which is like called wrap equals to 2. So this way it is like 2 by 2 metric and looks much more beautiful than the previous chart. So using the parameter which is call underscore wrap gives you this flexibility, and this way your analysis become much easier. You can compare these 4 charts much easier and derive the observations out of it. Alright, so once we have this, I'll just copy this and paste it here, and then let's say along with this you want some more information like order priority, for example, to be color coded over here. So what you can do is use the hue as a parameter and say order priority. This way you will have the order priority highlighted for each chart. So if I just go ahead and execute that, you will see the chart is much more beautiful and the order priority is highlighted. Similarly, you can see the effect of ship mode. For example, if you are from the shipping department and want to understand the impact of ship mode on the various types of products that you are selling. So this is the effect of ship mode, where orange color seems to be highly dominating in this case, which is a delivery truck followed by regular air and then the express air. Also, it gives the information whether in high value orders what sort of shipping mode is getting used and things like that. Apart from this, if you want to make the analysis a little bit more complex, so for example we have the customer segment over here, and these are all the customer segment, but we also want to see it cross-section by the product category. Then what we can do is, let me just copy this and over here, and I will just remove this call wrap, and over here I will specify the opposite of column, which is row, equals to product category, and let's see the impact of this. Now the chart is being created. As you can see, it has taken some time, but this is now the chart for each product category and each product segment. So like products category is office supplies. Let me expand it a little bit so that you can clearly see it. Maybe furthermore. Yeah. So customer segment, let me just squeeze it. Yeah. So I hope this is visible, but what it is written over here is the customer segment, the product category office supplies, and the customer segment small business. So for each product category and each customer segment, a chart has been created for the different types of shipping mode. So this allows you to go really in depth into the data. And if you look at it over here, furniture and corporate, it is heavily influenced by the delivery truck, which makes sense also in this case. And over here, if you see, the regular air is seems to be in line along in comparison with the delivery truck, where regular air and delivery truck both are being used, and the product is basically the technology. And over here, this to me it seems like regular air and express air is taking the advantage or increment in as compared to the delivery truck, because again the product category is office supplies and customer segment is small business. So based on this analysis, you can come up with your strategies about or you can better understand which ship mode is being used by which type of product category and customer segment to better align and to improve your shipping related activities. So that's about how you can take an advantage of the different parameters like the column, row, and hue into the Seaborn, and go really in depth into the data and figure it out some hidden pattern which is sometimes not clearly visible when you look at the higher level graph. So that's about it, and I'll meet you in the next video with a new topic. Hi there, welcome back to the new video, and in this video I will show you the scatter chart but for categorical data. In the previous videos you must have seen that we have used both the numeric variables on x-axis and y-axis and showed the scatter plot, and that's how usually the scatter plot is created. But what if you have scatter or categorical data and you need to create a scatter chart? Well, Seaborn has an advantage over here where it allows to pick the categorical data and helps you create the scatter chart. Let's see how we can create it. So the data set we have been using is same. If I just show you over here, and to create the chart we will say sns.cat plot, which is category plot, and over here we want to take on x-axis we want to take let's say ship mode maybe, or whatever your interest is, like order priority or province or region, whatever you want to take. And y-axis is sales, and data is the sales object, the pandas object over here. And if you see, this is the categorical data, the regular air, delivery, truck, and express air, and this is a scatter chart basically showing you up until over here the data is really dense, but after that it becomes pretty much evident that there is a displacement or the space in the data. That means it is a bit open space as compared to the dense space. So dense space is indicating that more and more or most of the business is happening over there. So that's a very quick way how you can create a scatter plot along with the categorical features like shipping mode over here. Another important feature or a useful feature is, let's say you don't want to show this width, or you don't have an interest in the width maybe for your particular use case. So you can use the parameter which is jitter, and so this is called basically jittering, which shows the magnitude in the data. But if you don't want to see the magnitude, you can just get a line like this which sometimes shows the data patterns more clearly as compared to the magnitude, but sometimes magnitude is important. So we have both the features in hand, which we may want to use based on the scenario that we want to tackle. Apart from this, what we can basically take is or what we can basically do is querying the data directly in the cat plot or in any SNS or the Seaborn plot. So I'll just copy this and paste it over here. So I've not copied this and paste it over here. The only difference was jitter was not present, and we can have a dot notation over here after the pandas data set and say query. Within double quotation we can mention, let's say for example, we want to show where profit is greater than 1000, right? So if we execute this, again, the data is shown, but only for those data points where profit is greater than 1000. So this is also an amazing or a good feature where you want some customization into the data set. You can directly do it here and see the impact. Now, apart from this, what you have is a swarm plot, which is another very beautiful plot that you can create to show the magnitude of data. So I'll just copy this, and instead of jitter equals to false, I will write kind equals to, in double quotation, swarm. So this, when we create, this is how a swarm plot really looks like. Wherever the magnitude is high, it shows, then the magnitude is low, and so on and so forth. So this way it becomes really evident up until which part the magnitude is high, and then how the magnitude really looks like when you go little bit on the upper side over here, at least specific to this chart. The curve may be different for a different type of data. For example, in the middle you may have more magnitude, but not on the lower end or the higher end, right? So things like that becomes really evident or very much apparent when you use the swarm, the kind equals to swarm parameter, and create the swarm plot, which is another mode of the scatter plot. The last thing which I will show you is a bit of a trick over here, and which is about changing the parameters to make it horizontal. Right now if you see it as vertical, but if you want horizontal, then I can copy this, and its simple thing is ship mode, taking the ship mode from here to here. We may probably look for parameter or something when we don't know, and that basically going to take a lot of time. But idea is that on the x-axis take cells, and on the y-axis take ship mode, and the chart will change automatically from the vertical to the horizontal. So that's about how you can create the categorical scatter chart, and then the swarm plot that we discussed, the querying data that we discussed over here, to make our chart and make our analysis as in depth as we want. Hi there, welcome back to the next video, and in this video I will going to talk about some more Python Seaborn chart related to the data analysis. So before I start, just wanted to ask if there is any other tutorial related to the Seaborn that you would like to see, or the chart that you would like to see, probably which I have not covered so far. However, I have a plan to show the relational chart and all, but if you have anything particular in mind and you think will be useful for others as well, let me know in the comments and I will try to create the video tutorial for that. Alright, so the chart that I want to show you today is basically comes in the categorical charting category, and this basically shows the overall distribution of data along with outliers. So probably you have predicted the chart by now, but if not, I am talking about the box plot chart. So box plot chart helps you understand how your data is distributed over the quartiles, and what the median is and what the outliers are, so that you can really take the advantage of the visualization by quickly identifying whether this is as per your expectations or not. And visualization really helps us understanding what's really going with the data as compared to our assumption. So let's see how we can create it. Well, I have already imported the Seaborn library and the data. So if I just show you the same data set which I have been using, so what I'll do is I will just delete it. I press 2 times T, that's a shortcut. Again, I'm telling you, however, I have created a separate video for those shortcuts. But if you are coming out of this and by pressing escape and enter D 2 times, D is Delhi, so D 2 times if you press, the row will be deleted. Alright, so SNS is basically the alias of the Seaborn library that I imported, and the cat plot. Here we will specify on the x-axis the categories. Let's say we want product category, and on the y-axis, let's say this time we take a different variable. Maybe we want to understand the shipping cost that is associated with each category. Data equals to sales and kind equals to box. All right, let's enter this. And here is a chart that is clearly showing you the distribution of 3 different categories for shipping cost. So on the y-axis you have shipping cost, on the x-axis you have categories. So office supplies and the technology indicates that their average cost, the average shipping cost is very low, which is this line, the middle line over here, and this one, as compared to this one, the furniture item, probably because the furniture item is pretty bulky in nature, and that's why they require more cost. And another thing, you see that in case of office supplies, you have more outliers as compared to the other 2 categories. So that's a quick observation that you can make related to this box plot chart. But it doesn't only show this, how it shows other information about the upper whisker, the lower whisker, what is the first 25%, what is the value up till 0 to 50%, and things like that. If you are aware about the entire distribution of the box plot chart. But the journey doesn't stop here. So right now we are looking at the shipping cost. But let's say we want to understand the shipping cost from the shipping mode perspective. So what you can do is copy this. This is about drilling down into the data and better understand what is really going on when you further grill it. That's what you say, grilling the data. So what I'm adding over here is the hue parameter, and you will see it in a second what it will do. So ship mode, if I'm not wrong, that should be right. Yes. So ship mode is basically the regular air, delivery truck, and express air. And for all these 3 categories, 3 different chart is produced. One for regular air, then for express air, and this is delivery truck. Clearly I'm giving you an indication that delivery truck is, if you are shipping by delivery truck, the cost is really high. So if you see, it's a pretty nice observation as compared to this one. This is a very high level where we identified that furniture, the median cost of the furniture is really high. But when we look at from the shipping mode perspective, we clearly see that for office supply, the cost is going even higher than the furniture. So you may see that, or you may want to investigate that what is going on, what are all these products which is going even beyond the furniture, which in general is your highest shipping cost product category. Now after that, let's say you get a requirement that your management is used to of seeing this particular chart or these particular categories in a particular order. So for example, they want to see the categories, let's say what we have shown over here is regular air, delivery truck, and express air into a way where delivery truck is first, regular air is second, and express air is third. So in that case, what we can do is copy this. So this is about bit of a formatting, which is also an important part. And after this hue, I will add a comma, but it doesn't really matter. I can add it at the end as well, but since it is related to hue, that's why I am adding the parameter over here. So in hue, we will pass on the list that first is delivery truck, then second is regular air, and then third is express air. I think it should be okay now. So yes, as you can see, you have formatted the chart based on the request you got that delivery truck should come first, then the regular air, then the express air. All right. Now, after this, let's say you get one more requirement. So what they told you that this chart looks good, but they want to evaluate all these three categories independently from the presentation perspective. So what you can do is you can come over here, or maybe not this one, but maybe this one, because I don't want order in that case. So over here, so this will produce a chart like this, where for these three product category, these are the three ship modes. So let me execute and show you. It's the same implementation that we did earlier. Now we want an individual chart for regular air, delivery truck, and express air. So in that case, what I can add is row instead of hue. That for each row we need one chart, and there will be three charts in that case. So if I just execute this, as you can see, ship mode is regular air over here, then ship mode is delivery truck, then ship mode is express air, right? So this way you can create a chart like this. And let's say if they, after seeing this chart, they say that no, we probably need it in a one single row. That means after this chart you have chart over here, chart over here. So that's how requirements keeps changing, and what you can take is an advantage of the column parameter COL. So earlier, as you know, we used row, but now we will be using col, which is nothing but the column, which says that put all the charts in one single column. So if I just execute it, all these three charts in the one single column, and they are sharing the same y-axis. This way, I feel that this is a much better representation than the earlier one, which was row. This way I can, analyze each chart individually, and they are well formatted in one single line, which I can put it in a proper presentation or a report as well. After that, one last thing which I will show you is one next level of complexity. Let's say we want to analyze all this, but along with each customer segment. So under each customer segment, whether it is home office or corporate or consumer or small business, what are our shipping mode by these, all these categories and all these product categories. So over here, the only thing you need to add is the previous parameter, which is row, and you need to say customer segments. So this will make things a little bit more complex, but it will going to grill the data a lot. So if I just execute it, you will see a lot of charts. So here we see the chart for customer segment, which is small business, regular air, small business, delivery truck, small business, express air, right? Then the customer segment is changing over here, and then finally the fourth customer segment. So this way you will make your visualization and data analysis skills to a next level. Also, this will help you grill the data a lot, so that you can clearly see the pattern where, let's say, you have outliers. So things like in customer segment consumer, only the delivery truck is having the outlier but not the other two. And you will see similar sort of observations which is related to the distribution and the outliers into all these different charts. But that's about how you can go really inside into the data using the box plot chart and make an impact with your data analysis. So that's about it. Let me know how did you find it, and yeah, leave me a comment with what do you want to see next, and hopefully I'll try to prepare a video for that. Hi there, welcome back to the next video about the Seaborn tutorial. And in this video tutorial I will going to talk about the Violin chart, which is a very special kind of chart and a combination of KDE, which is a kernel density estimate, and the box plot chart for showing you the richer distribution of data along with the whisker and quartile information. So let's see how we can create Violin chart. And before I do that, let me know if you want to see anything other than that related to the Seaborn tutorial based on the tutorials I have already shared. And let me know in the comments about what else you would like to see from the Seaborn data visualization perspective, and I'll try to create a chart for that. Alright, so the data that I am using, if you are watching my previous video or following the videos that I've already posted, it's about sales data set. So just to show you sales.head, and this is the data set that we have been using. It's having a lot of close to real data, but again it's one of the dummy data which has been provided, and has some around 10,000 rows which mimics the real life operations of a company, includes the order, priority, sales, discount, ship mode, things like that. And let's say we want to create a Violin chart. So what do we want is SNS. SNS is nothing but the alias for Seaborn library that I created earlier. So Seaborn.getPlot, and on x-axis I'm using the same example that I showed in the previous video for box plot, so that there is some relation that you can find it, and it will be easy to understand as well for a new chart perspective. So product category, and then on y-axis let's say you want shipping cost, and what I can do here, what I need to specify for Violin is kind equals to Violin. Alright, let me see if I have done, could not enter product category. Alright. Alright, so one more element, which is data equals to sales. Alright, so here we have a chart, and this, as you can see, shows in the middle the representation of box plot. Over here, the box plot, as you can see, having a wider width in terms of the length, and this basically indicates where most of the aggregation of the data is, and then over here, then over here. So as you can see, it's like much better representation of how the data is distributed, and where it is more condensed, along with the categorical data to see the spread of the data as well. Now let's say you want to see the shipping cost by their respective shipping mode. So if I paste it over here, one of the parameter which you might have seen earlier is the hue, and there we can specify the ship mode, and it will going to create the three different distribution over here for regular air, delivery truck, and express air, clearly indicating the difference between the three ones. Apart from this, the next level of visualization that we can do inside is related to specifying the sort of a stick or lines. So even the parameter name is same, where the inner part says inner equals to, you can specify that you want stick, which will show you the data condensed over here, and that's the reason, you know, these shapes are like this. So it will take some time based on how long or how big the data is, but my advice is, to apply it on the small data. Otherwise it may take like forever to display that, because it's a very condensed and very detailed visualization, because it is trying to plot all the rows really that you are having in the data set. All right, so it took some more seconds, like around 3-4 more seconds, and now you have the stick over here. As you can see, some dashes over there, which basically indicates how dense the information is present at that part of the visualization. Apart from this, apart from inner equals to stick, you have similar more parameters that we have used in the previous tutorials. So if I just come here and press shift tab twice, you will see that we have used hue. We have row parameter that we have used earlier to divide each chart into a row, or divide each chart into a column. By default it comes with a confidence interval. By default estimator is the function mean. So you can actually look at over here the different parameters that we have and experiment with it. Down there you will find a lot of explanation about the parameters that are there, along with the information about some of the exercises. Hi there, welcome back to the new video, and in this video I will show you how you can create a bar chart. So yeah, bar chart. Without bar chart, every visualization tutorial is incomplete, because this is the most favorite chart and most easy to understand chart. And now in Seaborn I will show you how you can create a bar chart. But before I move ahead, apart from all the tutorials that I've shared, if you want to see anything else in the Seaborn tutorial, you let me know in the comments, and I'll try to create a chart about it and post it here in the channel. Alright, so the data that we have been using, if you're following my previous videos, it's the sales data. So just to show you the data set, this is what the data set looks like. So if I press DD, it will be removed, but it is close to real data set, again based on some dummy sales store. It's about all the orders which have been served by that sales store. So what do we want to create is the bar chart. So SNS dot not the bar, cat plot, category plot, because bar chart is nothing but the category plot, where on the x-axis you have categories, on the y-axis you have the continuous variable. So x equals to, let's say, product category, and y equals to, let's say, sales data equals to sales, and kind equals to bar. Oops, okay, could not interpret product category. All right, data equals to sales, so no problem. What we want is sales dot columns, and it will show us the columns. Product category, I think that's what I have written over here. Product category. I think this doesn't make any issue, the single quotation. Sales, let me just recheck. Could not interpret input product category. SNS dot cat plot. Let me add this. Yeah, so maybe I made some mistake over there while writing it. So it's a very simple chart. Over here you have the error bars, and on the categories you have the 3 different categories and their respective values. So it's a very simple and straightforward bar chart in the Seaborn. but you can make it complex by adding more parameter like hue. You want to see it, let's say, by shipping mode, right? So all these three different shipping mode is basically will be displayed over here along with your error bars. Apart from this, like you have seen in the previous videos, you have a lot of different options like how do you want hue, whether you want row, like for each individual row you want to have some values. For example, if you have not seen the previous video, row equals to, let's say, customer segment, and this will produce for small business, this is the chart. For consumer, this is the chart. For corporate, this is the chart. So for each customer segment, it will create a chart. So sort of a loop. But if you want in one single column, you can specify call, and you will get all these 4 different charts: small business, consumer, corporate, and home office in one single row for better comparison perspective. But yeah, you can evaluate all those different options which are there. As you know, these are pretty straightforward, but require some time if you are not using it right. But down there you have a lot of explanation, and over here some examples like how to put it, and you can take an advantage of that. But yeah, if there is anything where you are finding difficulty, let me know into the comments, and I'll try to reply with the answer if I know, and hopefully that will help you. And maybe one last thing which I will just inform you about: changing the orientation. So right now it's a vertical chart, but if you want horizontal, well, it's a straightforward. There is no parameter over here, but what you can do is I will just remove this these 2 parameters just to make it like little simple. However, it will not have any problem if we are keeping that. So we will just say y equals to product category and x equals to sales. That's it, and you will have a chart like that. So if you may wonder or maybe searching for a parameter for the horizontal chart like this, then that's not there. You just need to change the x and y categories like I just did, and you will find a good looking bar chart over here as per your needs. So that's about it. Let me know what do you how did you find it in the comments, and I'll meet you in the next video with a new topic. Hi there, welcome back to the next video. And in this video I will show you the point plot, which is another way of visualizing the data clearly and may be helpful for you in certain scenario. So we'll see how we can create this point plot in Seaborn using the same data that we have been using. And as usual, before I move ahead, if you have anything related to the Seaborn that you would like to see and which I have not covered, let me know in the comments, and I will try to put together a video for that and post it here for everyone's benefit. Alright, so the data that we have been using is the sales data, and just to show you quickly, if you are watching it first time, this is how the data looks like. You have a lot of different columns related to the orders, sales, discount, customer, product, so on and so forth. Alright, so what do we want is basically a point plot, and just to show you the very basic point plot, sns.cat plot, category plot, x equals to product category. I guess I'm writing it correctly because earlier product category, yeah, sounds fine, and y equals to, we have, let's say, sales is one of the parameter which is here, sales, and data equals to sales, it's the sales object which is here, that's the data set, and here we will say kind equals to point small, that we want a point chart. Alright, so that's how usually a point chart really looks like, connecting the different point along with the error bars that we saw earlier with the bar chart, that it creates an error bar around it based on the not the errors, but the variation in the data. All right. So once we have this, let's try to extend this with one of the parameter that we have been using, and that is hue. And this is, we try to take ship mode. So what it will show is the sales for product category for all the shipping mode. All right, so let's execute this, and that's how your sales really look like by the shipping mode. So maybe, so it's the delivery truck where, you know, it's showing you the higher sales as compared to the other two categories, which is regular air and express air. But you can be innovative based on the dimension that you have. Let's say, for example, we have region, but there will be like a lot of data points. So let's see how it plots. Yeah, as I said, like there are like a lot of different data points, and it is trying to put a points on top of each other. That's why the visualization will look more complex. So I think the rule of the thumb is, if you have like 2 or 3 points which you're trying to connect, something like shipping mode over here, which was looking very well, and one can easily read it like this. Show us the clear demarcation between, or the, you know, differentiation between delivery truck and regular express air, regular/express air. Very easy to interpret what's going on over there. So if you have 2 or 3 categories, I think that's where it will look pretty nice and show how the points are connected to each other along with the parts. Shows the in furniture, the variation is less compared to the office supplies, where the variation is high, and somehow similar variation in data in the technology as a product category. But like any other chart, it has a lot of different charts, so like column or row. So maybe, for example, you want to show this for each customer segment, so you can say row equals to customer segment, and it will show for all the 3 customer segment, which is, oh sorry, 4 segment, which is small business, consumer, corporate, and home office. And if you wanted one single row, then just say com. Well, this is something which I have shown in every video, just so that you know, we are at the end of this tutorial very much perfect with the using all these variables, so, or the parameters over here, which is part of this function, and we will be able to use it effectively in our real world data science problems. So that's about how you can create a point plot, which is a different type of plot within Seaborn, and gives a clear indication about how the points are connected to each other and what are the variation along with the error bars. So that's it, and let me know how did you find it, and I'll meet you in the next video with a new topic. Hi there, welcome back to the next video, and in this video I will going to show you how you can produce the distribution plots using the Seaborn library. So we will look at some of the functionalities of distribution, and then finally how we can fit the probability, some of the probability distributions like the gamma and the beta, which is more towards plotting the probability distributions that we will going to see. So let's see how we can achieve it. So first of all, we will going to import these 3 libraries, the Seaborn as SNS, Pandas as PD, and NumPy as NP. And before I move ahead, maybe what I can do is increase the font by Control plus. These are the previous ones which I showed you earlier. Alright, I think this should be good enough. Okay, so let's execute this. So sales equals to pd.read_Excel. We're going to import the first sheet of the sales.xls file. Now, if you want to look at some of the rows, if you have not seen my previous videos, then sales.head, what it shows is basically very close to a real life data set, which is having a lot of columns like what is the order ID, order date, priority, sales, discount, profit, customer name, so on and so forth. So that we can do a lot of good analysis on this data set, and you can find the link of the data set in the description. Alright, so once we have this, what we can do is produce a distribution plot on the numerical columns, which is like sales or the order quantity or profit, and it gives us an indication about where most of the values are lying, or what is the distribution of the data. So let's see it in action, and then you can better understand. So the first chart we will going to display is, let's say, on the sales values. So I'll just come over here, and it is sns.dist plot, and we will simply write one parameter, which is sales, which is the dataset object, and the variable name is sales. Alright, if we execute this, it will going to produce a chart like this, where you see most of the values are concentrated, which is near to 0, not exactly 0, but near to the 0, and then this particular value. But since the bin size is a lot of bin size, which shows the sales is in some cases going up till like 80,000, and this shows that it is a right skewed distribution, right? Similarly, if you have if you want to plot like any other variable, simply write sns.dist plot and say sales.profit, and that shows capital P, I guess. Right, sales.profit dist. Okay, so now if you see, this is a relatively different distribution as compared to this one. So in this case, there is sales which is starting from 0, nothing is going below to the 0, but in case of profit, it is going even below to the 0, and in extreme cases even up to the 10,000. So it shows a very good picture about your data set on the both side, the positive and the negative. And even in this case, if you see, most of the observation or the profit is lying, which is probably in hundreds or in 2 digits. So that's where you can see the data distribution. But there are various ways by which you can customize this plot, and let's see them in action. Well, the first thing is probably you may want is getting rid of this particular shape, which is coming over the distribution of the bars. So for that, what you can do is simply say sns.dist plot dist, that's a mistake I made earlier, sales.profit KDE equals to false. KDE is nothing but the kernel density estimation, which is producing this chart based on the density of the data, and that shows you the chart which probably you need in case if you don't need this one. But if you don't need the bar and you are good with shape, well, then in that case you can set a different parameter altogether. So what you can do is, instead of KDE, you can say hist, which is nothing but histogram equals to false. So what you are left with is only the shape, and histogram is not there. So these are some of the customization based on your needs of better representation of the data that you want to do in a report or in a presentation that you are preparing for the data exploration. Now there is one more interesting parameter. So if I just copy this and come it over here, which is rug, rug equals to true, and it shows based on how many data points you have in that bin, shows the concentration of that data set, and then how many data points you are having near to these extreme values on the left side and on the right side. So along with the shape, it shows the concentration of the data. So sometimes a very meaningful representation to show you or to identify where the concentration lies. So probably you may want to have a cut off from here to here to better understanding of data. You can also play around with bins. So if I just copy that and paste it here and say, let's say bins equals to 100 in this case, it will show, it will, create a visualization in a bit different way, but since it's an extreme value, so you may not be able to see a lot of change. But what I'll do is I'll just remove the hist in case if it shows better information. So this is the histogram, and I'll probably make KDE equals to false just to see the change in histogram. So if I don't have bins, an automatic bin is there, so if you observe, the bar is a bit thick as compared to the manual bin size that I specified. But I think this will be much more meaningful if, let's say, we want to just understand the data which is for one particular category of values or one particular region. So maybe over here we can probably say sales dot region equals to West, if I'm not wrong. Okay, so it gives us the data with little bit of different values. So as you can see, you can make it as complex as you want. Like I have just added sales dot region. Maybe I can simply add and sales dot since it is a profit should be greater than 0. I am only interested in seeing the distribution which is greater than 0 and surround everything over here and over here by these parentheses. And now you see a different distribution altogether. So up to us how we want to customize or how we want to really use the slice and dice of the data that we are having in hand. We can make it more complex with like having more condition, which is AND condition, like so over there if I go up, you have order quantity. You may want to see only those order quantity which is like above 50, or maybe ship mode, which is like regular air or delivery truck. And you have like a lot of parameters by which you can customize and go really in depth into the data. And that's what usually the data scientists do, where they look at the data from the various perspectives by slicing and dicing. All right, let's move on. The next parameter I want to show you, if I just go down there, paste it, SNS sales.profit, and let's keep everything over here. It's a simple chart, as you can see. There is a parameter which is BW, which is bandwidth, which basically says how tightly KDE really controls the estimation of the data. So, for example, by default it picks up a value and shows us an estimation by plotting this KDE plot, but we can start giving some arbitrary value. For example, start with 100, just all right. SNS.bit plot, this plot got unexpected. All right, my bad. I think that is your KDE plot. KDE plot, guess should work fine. All right, gives an error. Let's see this. Line 2D has no object. Okay, rug. This was related to the previous test plot. So if I execute this, it shows you a picture which is slightly different. If I just come up, SNS.testplot, sales.profit, if I just say that, this picture is comparatively more smooth. If you see the curves over here, which is right now not present over here. So this is basically saying like we create bins. It basically says how tightly it controls the data or the estimation of the data, and it's related to the kernel density estimation for purpose of, let's say, smoothing and seeing by this sort of a smoothing and tightly controlling the estimation that how the curves fit. And if I just try to experiment it with 1000, you will see that it becomes like a better normal shape. So it's about experimentation, that where you want the value of bandwidth in case you are going really deeper and trying to understand change the value of bandwidth. But just wanted to show you that this is a parameter which is available with the KDE plot. Sometimes statisticians want to have it as part of the control mechanism. Okay, now let's go ahead and import the SciPy library, which is the final part of this video about fitting or displaying the the plots, the distribution plots related to the probability distributions like gamma distribution, or there is a normal distribution, there is a chi-square distribution, so lot many distribution, but let's experiment with two and see it in action. So from SciPy import stats, all right, and over here let's create a variable a that is np dot random variable dot, it has distributions like what I was referring is gamma over here, and it will accept the two parameter. Let's give it 1, and the size of the distribution, let's give it like 200, and you can read about these distribution over here that it is a shape, scale, and size. Right now we are just giving a shape and the size parameter over here. Okay, so let's execute this and let's plot the distribution. So SNS dot dist plot, and we want to fit a. Now let's just plot a and see how it plots. So this is basically the random values that we have fetched from the gamma distribution, and this is the plot that we get. But we have the parameter which is a fit parameter that helps us determine the how we want to fit this distribution. So it's stats.gamma. So that's how you see the fit, the another fit over here with the help of the black line, and this indicates the gamma distribution. Now if you are a statistician and you have a good understanding about it, you will know that if I just decrease the value over here and plot it again, its value is changing, becoming like more right skewed, and if I'm changing it to let's say 9, and again it's becoming like more towards a normal distribution. So that's about the problem in hand and how you want to fit the distribution. But just wanted to show you the parameters that are available to fit the distribution. Maybe another distribution that we can fit is random dot beta, and it accepts the alpha and beta values, and the size parameter, let's keep it like 200, and SNS dot dist plot b, we can say fit equals to stats dot this is beta. All right, let's execute this. Seaborn has no attribute. All right, so now this distribution is coming in the black line, and the blue line is your KDE. If you want to hide it, you know what you need to do. I've already explained it. Comma. All right, so this is how your distribution really looks like when it is a beta distribution based on the random values that you are getting. But this is something which you can apply it when on the real data based on the fit that you have, and see based on the distribution that you have in hand which distribution it follows, whether it follows a gamma distribution, the beta, or anyone else. But this is a more of a theoretical concept which I'm not covering here, but I want to just show you how you can visualize these probability distribution data over here and apply the parameter which is fit and get it in the visual form. So that's about it in this video, and let me know how did you find it, and I'll meet you in the next video with a new topic. Hi there, welcome back to the next video, and in this video we will going to explore two very interesting chart for the data exploration perspective, which is joint plot and pair plot. So let's look at these plots and some of its property and see how it can be really useful for the data analysis. Alright, so let me execute these libraries which I have been using, and the sales data. So sales dot head, just to show you first two observations. And as you can see, if you're following this is repetitive, so you may skip this part, but those who are new, this is the different variables that we have. We have some continuous variable like the product based margin. We have some variables like profit, unit price, sales discount, and the categorical variables like the order priority and ship mode. So let's see how we can create a pair plot and the joint plots using these values. So let's first explore the joint plot. All right. So what we need is basically the sales and profit, let's say, which is easy to understand, and data equals to sales. If I execute this, you will see a scatter plot like this, but the joint plot has an interesting feature which basically helps us visualize the distribution of the data. So over here we have the sales data distribution, and over here we have the profit data distribution. So along with the scatter chart, if you are interested into going into more in depth of data about the distribution that it follows, you can follow the joint plot. So sales and profit. But if you are interested in any other variable, for example sales and its related discount, a very important information which usually people want to know about how the sales and discount is going. So this is basically the sales and discount chart. The first is the scatter chart. However, the distribution is not so great over here, but it shows where most of the distribution is. And then on the discount side, it shows up there the sales distribution, which was present in case of this chart as well. So you may have sales discount, or maybe something like sales and maybe product base margin. I hope I'm writing it correct. Yeah, so the value is correct. So with this, you can see the distribution of the product based margin. The first of all the scatter, then the product based margin distribution, and the sales distribution. So this plot is about, as I said earlier, it's about looking at the data in a form of scatter chart, and then you have the distribution of the data as well. All right, let's move on. On this chart, joint plot, if I just copy this and if I show you one other very interesting property, Control V, one other very interesting property, which is hex equals to true. If I just execute that, all right, throws an error. I guess there is some mistake I'm doing with the hex, and let's see, path collection object, no property hex. Okay, so I think if this is not the case, we have this kind equals to hex. All right, I guess that's the one issue. All right, I think that's good. So over here, now you see this is more of a hexabin, and the concentration of the value shows, or the dark colors over here shows the concentration of the values. So it looks like the values are over here from the product based margin and sales side, and over here as well. And another interesting chart from this, what we can make is, if I just paste it here, it's related to the discount, and if I execute this, it shows pretty interesting things like this. So over here one can very clearly visualize about the concentration of the values when the cross section of the product based margin discount happens, and over here in this range, which is between 0.6 and 0.5. But overall, this chart gives beautiful visualization and gives us the ability to better explain about what's really going on, where most of the concentration is, and very helpful in the analysis of fraud, or in the analysis of healthcare, where people want to see where the values are where the things are going wrong. They want to visualize this and they can clearly see about where the issue is or the problem lies. Apart from the kind which is hex, you can also have a kind which is KDE. So this also produce a similar sort of visualization, and as you can see, it takes time because it's a very advanced and that has to do a lot of processing. So over here, as you see, the chart is changing over here. But in this visualization, the things are becoming more and more clear along with the pattern of the data. And that's why it shows us much better picture if we compare to this one, and gives us more insight about the data. So this again, as you see, is more around the concentration of the data and their respective layers, how the data is moving, and down there over here, up over there, you don't have any high concentration, and then again concentration starting. So think like if you have any disease and you have a huge data and you want to plot it, this really gives us the great visualization from the perspective of just by looking at the data in this form. You can clearly detect what is going on with the data and where you really need to focus your attention. All right, after this, what we may want to look, or what I want to show you, is the pair plot. So far we were looking at the joint plot, but now let's look at the pair plot. So SNS dot pair plot, and first of all I will simply pass the entire data set, because what it does is it picks up all the numerical values and give you a good correlation chart. So let's execute this, and you will find it pretty interesting once the chart is visible. But as you can see, it is taking time, and it takes time when it produces it, because it is looking at all the columns and identifying which column is numeric, and then producing a very huge chart, which you will see in just few seconds, that it basically do a correlation or do a matchmaking with every variable which is numeric in nature, and then produces the sort of a scatter chart along with I believe histogram and the KDE plot. So if you have more huge data, and as you can see, even we don't have the chart right now, you may want to seriously reduce the data by having just limited amount of data along with the limited amount of variables. All right, so now the information is down, is here, and it has picked up everything like row ID, order quantity, sales, discount, profit, unit price, shopping cost, product based margin. So wherever it picked up the or saw the numerical value, it has picked up that particular one and created this entire chart, which is over here, as you can see, a cross section with the profit and row ID. So it doesn't make a lot of sense. And as I said, row ID or order ID, if it does not make sense in your case, or the real data set that you are using, then remove that, because the more column you will add, the more rows you will add, it will going to take a lot of time. So over here, if you see product based margin and the profit, a different sort of a chart altogether. Same is product based margin and unit price, and then their respective distribution of the data. So what is a product based margin distribution, what is a shipping cost distribution, what is a unit price distribution, profit distribution, discount distribution, now I can see it from here, sales distribution, order quantity, order ID, and finally row ID, which does not make any sense as it has no relevance. So that's the thing which you can produce with the help of the this beautiful pair plot command. And I really liked it because this really helped me see entire data in a perspective, or all the columns that I want to see. Now what I want to show you is an impact of a categorical variable on this. So the property which we have been using is hue, and let's say we want to take an effect of shipping mode, SHIP, ship mode. I guess that's the column. if I'm not wrong. Then now it will take a little bit more time, right? Because first it has to do the entire processing which I just said in this previous command, but on top of that, now it has to imply the fact of the shipping mode, and now we will get a very beautiful visualization which is having a color based on the impact of the shipping mode. So I'm pausing here because it may take like 30 seconds or so, so no point in keep going with that. All right, so we have the chart now, and as you can see, it is a very beautiful and a chart which gives you a lot of insights about the shipping mode, which is a regular air, delivery truck, and express air. From this chart, one can very clearly identify in many cases you have the express air which is dominating. Sometimes delivery truck is dominating, and very few times you have regular air which is dominating. So you can take an impact of any variable that you want, and this is also pretty nice about on product based margin, what is the impact of shipping mode, and it shows the KDE plot over here. So you can experiment with the hue, which is shipping mode, and there are a couple of other variables, I believe, like hue order, what order you want, and then some information about the variables. You can change the scatter chart from other chart by looking at documentation, and then a lot of other parameters that you can control. But this is like the minimum parameters one can give and get the output, which is pretty interesting to see. So all right, so that's about it, the joint plot and the pair plot which I wanted to show you, and I'll meet you then now in a new video with a new topic. But let me know how did you find it, and that will help me plan the future videos in a better way.